Hi everyone, welcome to my channel. Today I am going to discuss the topic called stellar spectroscopy. First of all, before going to stellar spectroscopy, it is a topic from astrophysics. Astrophysics is a study of the universe, or we can say the study of heavenly bodies which are in the space. It may be stars, and sun is the one of the star, and there are different types of stars in similar to that. And the study of heavenly bodies is nothing but the astronomy, and here is the concept which is under astrophysics, that is stellar spectroscopy. And this video contains the basic concepts of stellar spectroscopy, that is the study of stars of basic part, and this is the part 1. And here arises the two questions. First is number 1, what is stellar, and number 2, what is spectroscopy. First, let us know what is meant by spectroscopy. Spectroscopy is nothing but the study of spectral lines which are emitted from electron when jumps from one orbit to another orbit. There will be an absorption or either it may be an emission, and it produces the spectral lines like this. And here it is a sample how it is produced. When electrons absorb certain energy from light and jump into a higher energy, there will be an emission or absorption of energy. And here there is an absorption of energy where it is indicated by black lines. So, in similar way, the study of spectral lines emitted or absorbed by an object is nothing but the spectroscopy. So, the study of spectral lines which are emitted or absorbed by an object is known as spectroscopy. And here in this universe, every object is comprised of one or the other atom. So, even the plastic contains the hydrocarbons, or we can say polymers. So, even the stars contains the atoms, and these atoms can be studied using spectroscopy. Means in this universe every object is identical, means we can say every object contains one or the other atom which are identical. In similar way, there must be a different stars on the basis of atoms. So how it can be identified? It can be identified by using the topic called spectroscopy. And the the study of stars using the concept called spectroscopy is what is meant by stellar spectroscopy. The study of stars related to stars using the concept called spectroscopy is nothing but the stellar spectroscopy. Next is, what is star? Star is nothing but a hot balls of gas in a space which are far away from us. But this hot balls of gas contains some atoms, and there is a high temperature in this, and apparently because of the due to refraction we observe stars as in twinkling, but actually their shape is in a oval. So next, how the classification of stars is taken place. As the temperature increases, the wavelength goes on decreasing. Means here the highest temperature of the star is 30,000 Kelvin, which is in blue color. So the blue color has the shorter wavelength. So as the temperature increases, there is a shorter wavelength. So blue is the one color which has the shortest wavelength. Later on, as we can observe here, the temperature goes on. As the temperature goes on decreasing, there comes the largest wavelength, that is of red in color. Okay. So here you can distinguish on the basis of the color and on the basis of the temperature. Color is nothing but the wavelength. So indirectly we can say that temperature is inversely proportional to the wavelength. So here, have you ever wondered that the sun is also a star? And what is the temperature of the sun? It may be around, because we are getting the sun brightness according to sun luminosity, It is about 3.9 into 10 power 26 watt of luminosity it contains, and the temperature of the sun is about 4000 Kelvin, means it comes under orange color, means it is apparently the wavelength of the orange wavelength. So this is how the classification of the stars on the basis of the temperature is taken place. As the temperature goes on increasing, the wavelength goes on decreases. As the temperature goes on decreases, the wavelength goes on increases. So it is a reciprocal. And next comes the stellar distances. Stellar distances is nothing but it may be the distances between the two stars, or it may be the physical properties of stars like astronomical units. What is meant by astronomical units? Means the distance between the sun and the earth. You know that the sun is also a star. The distance between the sun and the earth is about 1.5 into 10 power 8 kilometer. This is the distance between the sun and the earth, and this is what is called as one astronomical unit. And next is light year. What is meant by light year? The light traveled, has the word itself says the definition of the light year, that is the light traveled in the year is called as an light year. So therefore the light, what is the speed of light? 3.0 into 10 power 8, and it is traveled in the year, that is 365 days multiplied with it, so that is called the light year. That is about L, and its SI unit is Ly. This is what the light year. And next is per second. Per second is nothing but the what is the radius. One astronomical unit is there now, that is the distance between the sun and the earth, that is about what is 1.5 into 10 power 8 kilometer. This distance covers an arc in 1 second, that is called as an per second. And next is the luminosity. Different stars has the different brightness, so the energy emitted by each star is called as an per second, means the energy emitted per second is what is called as a luminosity, or we can say the brightness emitted per unit second is called as a luminosity. And the luminosity of the sun, as I said, 3.9 into 10 power 26 watt. Okay, and stay tuned for the part 2. There will be detailed information in part 2, and this is just an introduction of stellar spectroscopy, which is nothing but the study of stars.